Hey everybody, my name is Michael McDowell, and it is great to be with you. I am so excited to talk to you today a little bit about how do we make math practices, so those instructional routines in mathematics, small and doable. And I want to give you an example of how we've been using our Foursquare model as a way to really be able to turnkey some of these practices so that teachers can use them quickly and then we can scale them and then use them routinely. So what we've been doing in our professional learning is following a see one, do one, teach one approach to really be able to help with practice-based types of learning. So we see a lot of professional learning with lots of writing, lots of theory, lots of frameworks, but often what we don't see is moving from idea into implementation and doing that within these particular practices. And so Huberman was illustrating in one of his podcasts, then I went and I spent some time looking at medicine and what they use to really be able to help surgeons be able to engage in a particular practice, which is they need to see it, they then need to do one, hopefully like with a cadaver, and then they then teach that to each other to make sure that they solidify that before they go out and engage in that even in instructional or in rounds. And when they do those types of medical rounds, they're probably likely doing these three things when they're doing that as well. And so the C one is a structured observation and analysis. The do one is implementation with some level of feedback. And then the teach one is sharing some expertise and preparing to implement in classroom. So if you're running any professional learning, this might be a way that you think about even structuring your agenda of I'm going to show it, we're going to do one, they're going to then teach one there in that particular session. And then thinking about a number of strategies that you can do that with given the amount of time that you have, and then having some kind of coaching or some way of supporting teams as they go and roll that out. Anything that we do, we have this is our checklist. We need to make it manageable. It has to be routine. It can't be an event. We have to make sure we can link this to our current practice. We have to make sure that we're not adding more or that we need to find a way to be able to reduce so that we could bring a practice like this in. You can't just continue to add. We have to find ways to test our ideas so that it's small and doable. So if you're in a secondary context, then you might do this in like one class and not all of your classes, not all of your sections. Or if you're in elementary, you might pick a small targeted group, or you might pick one discipline that you try a particular practice. And then after a few weeks, once you've kind of gotten some experience around this and you have some evidence to look at what you're finding from students, then you look to see, okay, how would we then scale that kind of work? And then you obviously should share that impact with others and share out, what did you learn and what have others learned? Because I think it always builds better an understanding and next steps based on sharing our ideas, which is somewhat of what we're trying to do within professional learning community work. So there's lots of different math protocols. I've just put some of them here. There's three interval turn and talks, choral and echo reading. There's silent protocol, direct modeling, backward fading. There's all sorts of different practices. And what I thought I would do in this video is show you one example of how we could do the see one, do one, teach one, and how we could do that within one of our math protocols. And the one that I've decided to use within this particular video, and again, I'm happy to, if you want to reach out and talk through any of these practices, I'm happy to do that with you. The one I thought we would look at today is on numberless and slow reveal problems and why we would use this practice and then how I would run this in professional learning if I was to then go and teach this with a math department today. So I want to give you an example of a problem that I was working in a school district, and we were looking at one of the problems that students were receiving as a common assessment that they were having to do at the district level. And this was a sixth grade question that students needed to solve. And as you can see, there's some statement of like context for the particular problem. There's some data that students have, and then they have a drop-down menu with multiple questions, 3 questions that they have to be able to answer for this particular CFA. And so most of the students in this particular district found this question very difficult. Many students got the question wrong. They might have gotten part of the question right, but they got some of the question wrong. And a lot of that likely has to do with sense making. How do we make sense of a problem when there's so much going on within the problem? Because this is clearly more than that DOK or depth of knowledge level 1, or what I typically use as surface level knowledge. This is really going to more of a complex type of question. And what do students do so that they can understand a problem and not just jump to the question and then go back and try to search for answers? They actually need to think mathematically to do this problem. So what we do is, so we walk through, okay, well, let's look at a routine that might help. And we're going to go through the C1. So in the C1, what we do is we walk through the 4 steps. So step 1 would be students read the problem with limited information. We take the numbers out, we take the questions out, and we ask students, hey, what do you notice? What do you wonder? We could do this with graphical data, or we could do this with the actual we could do this with procedural data as well. And so when we look at that particular problem, we might say, okay, well, let's go through step 1. What's going on without any particular numbers? And so here would be that first part of the question. So Jane, Charlotte, and Lizzie each received a weekly allowance, which they save every week. And so this is a place where I might ask students like, what do we notice? What do we wonder? What's important to us? What stands out here? And hopefully the students would say something like, well, we know that we need to have, there's 3 people. We know that they get a weekly allowance, and we know that there's some kind of savings each and every week. So those would be the things that are really important. So then we might say, okay, so now we're going to go to step 2. And this is where students read the situation and now with numbers, and they start to identify potential questions. This could have multiple steps. So in that question I shared with you, it typically does, or it will. And so I might start with this to say, okay, well, what do we notice? What do we wonder? What do you think might be in the different columns? So when we think about weeks, what do we think we might see with Jane with the total allowance saved? What do we think we might see? So the students might guess. They might say, well, we should see week 1, week 2, week 3, week 4, week 5 across all 3 of these. And I could say, could they be the same? Could they be different across all of them? We have the students have a conversation. And then I give them this and say, well, what do we notice? What do we wonder? And usually the students, their prediction was wrong. They thought, well, it didn't start at week 1, it started at week 2. And I might have them make some guesses like, well, what do you think week 1 might be? What do you think week 3 might be? And the students might say, well, we think week 1 is going to be $6, but it doesn't necessarily have to be. We know from looking at the problem that likely is going to be 6. But we also might not know depending on what week 3 might be, week 4 might be. So then we show them this, and then they look at that and they say, well, actually, yes, we do see that. We do see that there is a pattern, and week 1 would likely be 6, because if you look at week 5 and you take 5 and you multiply that by 6, you're going to get 30. So there's clearly a ratio that's coming out from this. And then we say, okay, well, now looking at that, let's look at the data from all 3 of the tables. And this is where I start to say, what questions could you come up with based on the data that we have? And the students usually will say things like, well, we could ask questions of who has more savings. We could have questions about what happens at a certain week. So week 10 or week 11 or week 12 or week 15 or week 20. And we actually have students start to generate different types of questions. Then what we do is we actually have students answer the questions they created. Unless they ask a question which mathematically they don't have the background knowledge in order to do, if they've asked questions that they actually know the answer to, we actually have them go and answer them. And so this might be the place where I say to the students, okay, you asked these 4 questions, let's go and try to answer those. And then step 4 is we actually have students identify the actual problems and solve. So now we give them the actual questions and we actually have them go solve. 9 times out of 10, the students have actually selected problems that the tests have. And when they don't, they've actually done the thinking in order to do this. This allows me to actually reflect with students on what happened as we went through this. And the students spend a lot of time talking about their thinking about the mathematics. They're making sense of these problems. So numberless word problems or slow reveal, depending if you're using graphs, it's a really nice way to help students make predictions, make sense of things, and to slow down in order to do this work. I will also say, in my experience working with students, is that it also doesn't take as much mental energy when we do it the way that I just proposed it, because by slowly thinking through it, they're actually not as exhausted than they are jumping to the question and just trying to fish for things and then getting worried and stressed. And it's kind of a snowball effect as they go through multiple problems. So that would be a C1. I'd walk them through, like if I was doing professional learning with staff, I'd walk them through it and say, those are the 4 steps. That's an example of one. And then I would have them do one. I'd be like, okay, we're going to do one together. So step 1, read the problem with limited information, no numbers, no questions. And I might give them something like this. There are 2 tigers at the zoo. The weight of the younger tiger is some number of pounds. And then we would go through it. I'd be like, okay, what do we know? What do we notice? What do we wonder? And then I would do step two. Students read the situation with numbers and identify potential questions. So I give them more information. What do we know? What questions do we have? Now I give them more information. Now I give them more information. I'd say, what questions can we come up with? And so in step three, they might come up with questions like, how much does the older tiger weigh? How much do the tigers weigh altogether? What is the difference in weights between the two tigers? And then when I get to step four, I'd say, okay, so the actual question was, how much does the older tiger weigh? They're like, oh, okay, well, we've already solved this. And that's the way that we do it. So I'd see it, show them the four steps, do one, we do it together, and then I would actually have them teach one. Now, depending on your time, you might say, okay, I want you to come up with a problem and then model it at your table groups. And I'm going to walk around, or we're going to walk around and support you. And each of you is going to teach one. You might have them rotate around. So people are teaching to different people. Or you might say, look, you're going to prep how you would teach this in class, and then we're going to give you feedback on how you would teach it within your lesson. That's really depends on where you are. My suggestion is actually have them model and give feedback so they actually get the practice of going through it. If you're going to do a few of these throughout a professional development session, you might rotate them. So you might say, this one you're actually going to teach, the next one I want you to prep and give feedback. And that's how we would do it. So the numberless word problem, just to go back through and what are the four steps? Students read the problem with limited information. They read it, the situation with numbers, and identify potential questions. They answer the questions they've come up with. And then students identify the actual problem and solve. And if you're running the professional learning, you would do this by showing them all four of these, then doing them together, and then having them teach those. So you need to give yourself a good, I'd say 90 minutes or so to go through that practice. Make sure people have enough time to teach one another and to give feedback. I think that's the one that we kind of skip. We're like, okay, you know that you should maybe bring that in at some point in time. And that's likely going to prevent people from actually doing it. Or if they do, they'll do it once, but not multiple times. And this work has to be a routine, not an event. If you just do it once or twice with kids, it's not going to make much of a difference. Then behind all of this, that's when then you have to look at coaching and bringing this into PLCs to provide that support. But this would be a way of taking professional learning and really making sure that it's practice-based learning so that it can actually be infused over time. So that's just kind of an idea of how you could use the see one, do one, teach one with small doable routines. We have lots of math routines that you can look at within our Re-envisioning Rigor book. If you go onto Amazon and type in Re-envisioning Rigor, there's lots of these strategies that are in my Rigor Redefined book through Solution Tree. Also, you can access that on Amazon. Feel free to reach out to us at Hinge Education if you have any questions in relationship to the work around professional learning or on how we would execute some of these practices in mathematics. It might be in procedural fluency. So things like our silent protocol and backward fading is really, really helpful with that. Conceptual understanding would be more on like looking at our two-box induction, our SSDD problems, and then moving to application-based mathematics, you might look at things like the three reads and what we just saw with the numberless word problems / slow reveal. Anyway, thanks everybody. Have a great day.